Howdy everyone, and welcome to a short video about how to interpret the lab data spreadsheet that you'll be able to access from Canvas for lab number 4. So this is just a PDF of the spreadsheet that you'll be able to open on your computer. And what you'll notice, of course, is that all of the same columns of data that you have available to you on the spreadsheet are also shown here. And so we have, for example, all of the crank angle data that's shown in this column, and the crank angle data runs from minus 180 to positive 180 because this is for a two-stroke engine. And so one complete cycle is done within 360 degrees. And so we orient the data to be from minus 180 to positive 180. And then there's a series of columns that are to the right of the crank angle data. And so we have, for example, 1, 2, 3, 4, 5 columns of data that correspond to the engine operating at 525 RPM. And then there's another set of data, 1, 2, 3, 4, 5 columns of data that correspond to the engine operating at 475 RPM, revolutions per minute. So this engine that you're studying is a large bore natural gas engine. If you ever drive through the Texas countryside and you see those pump jacks that are drawing oil and gas out of wells, those are very often driven by what we call pump jack engines. And the most common or the most prolific of these engines that were made is an engine called the Ajax E565. And essentially this 565 was the specifying the displacement of the engine. And so these engines are located all throughout, obviously not just Texas, but throughout the countryside, wherever you need a pump jack engine operating. So they're low-speed machines. They're not necessarily very powerful machines because the engine speed is low, but they produce an enormous amount of torque. And so they're single-cylinder engines, and they are about 9 liters in displacement. And you can see over here how much torque they're making, right? They're making just a little less than 500 foot-pounds of torque at their peak condition, right? And so anyway, back to the data. So all of these columns of data that you see, 1 through 5 for the speed of 525 RPM, 1 through 5 at 475 RPM, these are all individual measured pressure data from the engine cylinder at those respective speeds, okay? And so you can see at minus 180, this is, of course, during the gas exchange process. So the pressures are low, and so we have pressures of, ranging from 101 kPa, basically all through 101 kPa, at least through the first 20 crank angle degrees of the cycle's operation. So the gas exchange process lasts for at least somewhere around 80 to 90 crank angle degrees. So you won't see these pressures rising until you get to about 90 degrees before top dead center, or negative 90 degrees, okay? So that's one additional item to note before I explain what each of the 5 columns refers to. So when you see this minus 180, what that really means is that's 180 degrees before top dead center. And so the units on crank angle would be degrees after top dead center, okay? And so minus 180 means that it's, negative 180 degrees after top dead center, or 180 degrees before top dead center. When you get further into the spreadsheet, you'll find 0 degrees, which of course would be top dead center, and then the crank angle values will all be positive, which is to say that now you are positive degrees after top dead center. So each of the 5 columns that we have for each of the speeds, right? We have five columns for 525 RPM, 5 columns for 475 RPM. So each of those columns refers to a specific spark timing of the engine. And so what we're varying for each speed is the spark timing, the timing at which the spark releases inside the mixture. And so we're varying the spark timing at 525 RPM as well as 475 RPM. We're varying the spark timing to 1 degree before top dead center, 6 degrees before top dead center, 11 degrees before top dead center, 16 degrees before top dead center, and then finally 21 degrees before top dead center. And all those same spark timings are used at 475 RPM as well, okay? And so you'll be able to analyze all of those pieces of data at the various spark timings and for the two different engine speeds. Then the final column of data that's given to you is the volume of the engine. Note that this is in liters, okay? And so this is the total volume of the cylinder in liters. And you'll, of course, need to know that information. In 410, obviously, you'll need to know that to calculate the indicated mean effective pressure, very similar to what you did way back when in homework number 2. But then also the 611 students will need that to calculate rate of heat release as stipulated in that equation that's given to you in the lab handout. Okay, so we also have listed in the spreadsheet the brake torque for each of the spark timings at the two different speeds. So there's a chunk of data for 525 RPM and another block of data for 475 RPM. Note that the brake torque is provided in foot-pounds, so make sure that you're consistent with your units. If you're calculating things like brake mean effective pressure, you're not asked to, but if you do any kind of calculation or reporting, make sure that you note that this is in foot-pounds, okay? You can ignore this voltage column here. This is what we actually measure, is the voltage from the strain gauge, and then we apply a calibration factor to that voltage to actually get the brake torque that's being reported to you in this column here. And then the final block of data that you'll see listed is the combustion locations. So we have listed, of course, the spark timing, right? And so 1 degree before top dead center means a spark timing of -1 degrees after top dead center, right? 6 degrees before top dead center is -6 degrees before -6 degrees after top dead center, so on and so forth for -11, -16, and -21. And of course, there's a separation for data at 525 RPM, data at 475 RPM. And then each of the values within the table then correspond to the 3 major combustion locations that we talked about. Crank angle 10, which is the 10% mass fraction burn, right? So CA10 is the same as 10% mass fraction burn. And the same with CA50, of course, is 50% mass fraction burn. And then CA90 is, of course, 90% mass fraction burned, okay? And so you can see here that 90% mass fraction burned for 525 RPM at -1 degree spark timing occurs at 52 degrees after top dead center, okay, 52.34 degrees, okay? Okay, now in the 611 students will know this, but of course in MEEN 611, you're expected to yourself determine these values based on your calculated mass fraction burn data. And so you can use these data, though, to help you verify whether or not you're doing that mass fraction burn calculation correctly, okay? All right, so that's how you use the data in this spreadsheet. And also be sure to watch the video for each respective class, MEEN 410 and MEEN 611, to know how to do your respective labs. Thank you all so much. Have a